Hello friends, welcome back. In this session, we are going to discuss the key hardware types for AI deployment. After listening to this session, you will get answers for the questions that could be: what are the core deployment strategies for different hardware like CPU, GPU and NPU? Why deploying AI across diverse devices is essential for achieving optimal performance and scalability? What are the steps that are required to be thought of when you are going with diverse hardware? All this will be answered when you listen to this session. Let's get into this session straight away. The deployment strategies for different hardware. It can be CPU, GPU and NPU. In the field of AI, hardware selection play a very crucial role in ensuring that models perform efficiently and scale to meet real-world demands. The choice of hardware significantly impacts speed, accuracy, and cost effectiveness of deploying a range of AI models, from vision-based applications to the modern Gen AI applications and LLMs. Different types of hardware, AI tasks, including deep learning on large dataset, real-time inference on edge devices, and high complexity processing for tasks like the text generation, image creation, and whatnot. All these are to be considered. Selecting the right hardware for deployment is really essential to achieve optimal performance and operational efficiency. Let's start with CPUs. CPUs are versatile and can handle variety of AI tasks. Though they may not match the speed of specialized accelerators for deep learning, it is still important to have CPU. With OpenVINO's optimizations, CPUs can run models more efficiently, supporting vision-based models, LLMs and Gen AI applications where real-time response is not as critical, but reliability and cost effectiveness are priorities. Let's get now to GPU. The graphics processing units are highly parallel processors designed for complex computations, making them ideal for deep learning, vision-based models and even Gen AI tasks that require high processing power. For applications demanding high throughput or handling large datasets, GPUs excel by providing substantial computational power. OpenVINO's performance hints further optimize AI models for faster inference rates on GPUs, which is certainly beneficial for both batch and real-time processing. So GPUs are very important. Now comes NPU, which is the newborn baby in the town, the neural processing units. NPUs are specialized processors optimized for AI-specific tasks, particularly in low-power environments like the mobile and the embedded systems. They are highly efficient at managing real-time, low-latency inference, and most importantly, for edge deployments involving vision-based models or lightweight LLMs. OpenVINO ensures that the AI models can run seamlessly on NPUs very effectively. It also ensures that enhancing performance is possible while minimizing energy consumption, making NPU a preferred choice for edge AI applications, which always requires efficient, responsive and scalable solutions. So we have got CPU, we have got GPU and we have got NPU, and everything is supported by OpenVINO. Optimizing deployment for business and operational needs is the next one to be discussed. Selecting the right hardware also depends on the AI model's requirement and business goals. For an instance, real-time applications like autonomous vehicle and smart cameras need low latency hardware like GPUs or NPUs for vision-based models. High throughput, large-scale processing in the cloud environment benefits from a combination of CPUs for general tasks and GPUs for intensive deep learning or Gen AI workloads. Edge deployments prioritizing energy efficiency relies solely on NPUs, where OpenVINO's optimization capabilities can help maintain high performance with minimal power usage. All these are very important to be understood. By understanding these deployment strategies, developers can choose hardware that balances the performance, scalability, cost effectiveness, ensuring applications like vision models, Gen AI and LLMs run seamlessly across varied environments. Now, we need to also understand how do we go ahead and optimize performance across different hardware. Optimizing performance is the most important thing that you have to do, and we have to learn that. Deploying AI models on the AI PC requires thoughtful optimization across CPU, GPU, and NPU resources. OpenVINO enables developers to leverage unique strength of each hardware type, whether it is CPU, GPU, or NPU, whether it is running models that need quick responses or handling data-heavy tasks. Now we are going to understand how do we optimize performance across different hardware. Deploying AI models on an AI PC requires thoughtful optimization across CPU, GPU, and NPU resources. The OpenVINO enables developers to leverage unique strengths of each hardware type, whether it's for running models that require quick responses or handling heavy tasks. We need to understand how to deploy inference tasks strategically to maximize the performance, achieve balanced resource use, and to meet the demands of varied AI applications. OpenVINO is going to help you in everything. OpenVINO simplifies the AI deployment by enabling a write once, deploy anywhere approach. This allows the developers to write inference code that run across multiple devices without major adjustments. The flexibility is very appreciable and very valuable when deploying AI models on diverse hardware like CPU, GPU, and NPU within an AI PC. So with OpenVINO, a single code base can take advantage of each device's strength, ensuring that performance is optimized regardless of underlying hardware. We need to understand how OpenVINO leverages each hardware type to maximize performance and efficiency for varied AI tasks. That's very important to be understood. We can utilize the CPU for versatile AI inference. The CPU offers flexible support for many AI tasks, especially useful for initial testing or for applications that don't require high-speed processing. With OpenVINO in hand and its optimizations coming handy, CPUs can handle models reliably and can be very ideal for tasks that prioritize cost effectiveness and general purpose AI deployments. To deploy a model on the CPU with OpenVINO, it's going to be very simple. The code is presented in front of you. The code leverages OpenVINO to compile the model specifically for the CPU. By just setting the device underscore name equal to CPU, the model benefits from OpenVINO's optimization for CPU-based inferencing, balancing computation power with efficient resource usage. This setup is very well suited for applications that do not require high throughput but benefit from consistent, stable performance. Let's get into the next one, which is going to be with the GPU. GPUs are well suited for high throughput tasks such as image classification, object detection, and running complex generative AI models, including LLMs. Their parallel processing abilities and capabilities enable a rapid handling of large datasets, making GPUs essential for applications that require real-time results and swift analysis. How do we get it? You can see the simple snapshot presented in front of you where the code is available, in which you need to just set the device underscore name as GPU. This way, we can enable OpenVINO to optimize the model for GPU-based inferencing. This configuration takes advantage of GPU's parallel computing power, making it well suited for intensive tasks needing fast processing of large datasets such as real-time image processing and advanced generative AI models. OpenVINO's optimizations help achieve high throughput and efficiency, particularly beneficial for multimodal AI workloads and LLMs that demand substantial computational powers. Next comes the NPU. It's going to be very important as well. Neural processing units are specifically designed to handle AI workloads with high efficiency and minimal latency, making it very suitable and ideal for real-time applications on the edge, such as object detection in the smart cameras, industrial automation, or other tasks that require immediate responses. The NPUs are highly energy efficient, which is beneficial for sustained AI operations in scenarios where power consumption can be definitely minimized. How do we go about it? How do we code? It's very simple. Setting the device underscore name equal to NPU in the OpenVINO toolkit enables the model for inference on the NPU. This configuration leverages the NPU's architecture, and most importantly, it is designed to handle AI tasks with low power requirements and minimal delay, making it ideal for applications requiring quick, efficient processing. OpenVINO's support for NPU enables developers to utilize these capabilities directly, ensuring real-time AI tasks are processed with optimal speed and energy efficiency. and we can go with automatic selection as well. OpenVINO offers an auto mode which is very useful and very easy for you. This mode automatically selects the most appropriate hardware device for the AI task, whether it's CPU, GPU or NPU. This feature simplifies the deployment process by enabling the toolkit to intelligently allocate resources based on the workload. Balancing the performance and the efficiency is also taken care, and without manual intervention this can happen. Auto mode is beneficial for dynamic environments where workload characteristics can change frequently, and it helps optimizing resource usage in real time. It can be automatic as well. That's it. I think we have completed this session nicely by giving you overview of CPU, GPU, NPU and auto mode as well. If you have any questions, go ahead and type it in the chat section. I'll be very happy to answer. If you like the channel, kindly subscribe. Thank you.